Hello everybody, welcome back. This is section 5.4, right triangle trigonometry. If you recall, we've been talking about trigonometry on a circle with an angle such as that. We call it theta. Then if we drop this perpendicular, we create a right triangle right there. And so what the suggestion is, we don't have to have this on a coordinate plane nor the unit circle. By the way, the circle could be big. This is y, this is x, and this would be r. If it's a unit circle, r is 1, and there's the sine, there's the cosine. If it's not a unit circle, that ratio is the sine, that ratio is the cosine. That's actually coming later. But so what the suggestion is, let's take this triangle away. There's a right triangle. There's no reason it has to be on a coordinate plane. And so we can talk about this triangle and pick a particular angle. Suppose that's the angle we're interested in. Well, over here this was y, but if it's not on a coordinate plane, we'll just call this opposite side. That's the opposite side from the angle. That's opposite. Then this side, the side that makes up the angle with the hypotenuse, we'll call that adjacent. And then, because it's a right triangle, this is the hypotenuse. Hypotenuse, I'm not sure what it's called. And so that's, it's no longer on the coordinate plane, it's just a right triangle. And there's three sides with respect to an angle. And then so we say that the sine of theta is the opposite over the hypotenuse. Y over r, if it's on the coordinate plane. Y over r, here it's opposite over hypotenuse. The cosine of theta is x, over here, x over r, adjacent over hypotenuse. Adjacent over hypotenuse. Then the tangent of theta, opposite over adjacent. Tangent, y over x, opposite over adjacent. And there you have it. That's SOHCAHTOA. Whether or not you choose to remember it like that, most people who have had trig that I've taught in the past, remember this. So, sine, opposite hypotenuse. Okay? Cosine, adjacent hypotenuse. TOA. Tangent, opposite adjacent. So, TOA. And so you have let's give a right triangle. We'll just give all the trig functions. Right triangle. Yeah, I have one. Let's make it 5, 12, 13. No, I think we used that already. 8, 15, 17. How's that? 8, 15. By the way, right there, you can find every single thing about that triangle right now. But it was because you used the Pythagorean theorem. And you'd find out that that's like 17. And so, now here's the thing. We'll call that theta. And we're interested in the sine of theta, the cosine of theta, and the tangent of theta. And if theta is there, the sine is opposite over hypotenuse. Sine of theta is 8/17. The cosine of theta is the adjacent over the hypotenuse. 15/17. The tangent of theta is opposite over adjacent. But now check this out. A right triangle has two acute angles. So that's from the perspective of there. We could go from the perspective of here. That's an alpha. The sine of alpha is opposite over adjacent. The cosine of alpha is opposite over hypotenuse, I'm sorry. The cosine of alpha is adjacent over hypotenuse. And the tangent of alpha is, of this angle, is opposite over adjacent. Now check this out. Of course, these two are called cofunctions because the sine of one angle is the cosine of the other. And we're going to talk about that in this tape. And then the tangent is would just be a reciprocal from which perspective? From the perspective of an angle. And so, from the perspective of an angle, is the point of this. There's two angles. We're talking, there's theta, here's alpha. Okay, so that's all that. And then right here, there's things called cofunction identity. Oh yeah, let's do this. Another right triangle. We'll call, instead of using theta, let's use alpha. We'll use alpha down here and beta up here. And just because, you know, this is opposite. This side we'll call y, this side we'll call x, this side we'll call h, or r. My point is the sine of theta, of alpha, is the cosine of beta. They're cofunction angles. That's what this board says. And then it goes backwards. Of course, the sine of beta is the cosine of alpha, just because it's backwards. They're cofunction. And from there, you could say the sine is pi over 2 minus the cosine, minus theta. No, sorry. The sine of theta, let's try that again. The sine of theta is cosine pi over 2 minus theta. 90 degrees minus theta. You know, these two have to add up to 90 degrees or pi over 2. And then the cosine of theta is also the sine pi over 2 minus theta. Because they're cofunction. That's what all this is about, cofunction identities. There's other identities. There's something called, well, because the functions are odd or even, there's odd-even identities. And there's only two you have to, well, we may as well remember three. The sine of a negative angle, negative theta, is negative sine theta. That's because it's an odd function. Cosine, on the other hand, is an even function. Cosine of negative theta is just a plain old cosine of theta. And then the tangent is an odd function as well. This came up, by the way, right at the end of the calculus class that I was teaching last semester, where we had to look these up. And that's what you do, you look them up. All these identities, they're there, they're written down for you somewhere, so you just have to look them up. One more thing, and this is an example, with just given a right triangle and an angle, you can get all 6 trig functions. For example, that angle is 30 degrees. And then suppose this opposite side is 7 and it's a right triangle. You can now find that entire triangle. We used to call it solvent triangles in geometry. You can find this side, and of course that angle is 60 degrees. So we'll call one side, let's call them A and B, I guess. We'll call this side A and this side, and the hypotenuse B. It doesn't matter. But just using the definition, sine of theta, 30 degrees, is opposite over hypotenuse. And we just solve for B. Sine of 30 is a half. B is 14. So now we have a side that's 14. A on the, now we can just use the Pythagorean theorem now. 7 squared plus this side squared is 14 squared. Or we could do another trig, say the cosine. We'll use the cosine of 30. Cosine of 30 degrees is A over 14. 14 times the cosine of 30, that is square root of 3 over 2. 14 times the cosine of 30. Check it out on your calculator, but don't check it out. You just remember it's the square root of 3 over 2. This is 14 root 3 over 2, or 7 root 3. That's the cosine of theta. Here's the sine of theta is 7/14, a half, 7/14. So there you go. You got the sine, you got the cosine. From there you can get the tangent of theta, would be the sine over the cosine, and you just get the other 6